All right, so when we first started, so basically, guys, we're kind of closing out our derivative section. Okay, we've pretty much learned everything that a derivative does, which of course is slope of a tangent line, instantaneous rate of change, instantaneous velocity, tells me increasing, decreasing. Second derivative tells me concavity. I should be able to tell the shape of a graph, extrema, all those stuff, related rates, all that stuff is from the first derivative. So when we first started derivatives, I told you, look, I'm going to show you the shortcuts first, which are your rules, your power rules, your quotient rules, your product rules, your chain rules. Those were technically the shortcuts before I show you the long version. Well, here we are. Okay, so this is technically the long version. Now, the thing is, it's not necessary. The reason it's long is just because it's algebra heavy. Okay, so everybody has to have their algebra hats on today, because we're going to be using the heck out of it. Okay, it's literally just algebra. So by definition, technically, by definition, the derivative of any function is technically a limit. Okay, so the limit is used to define the slope of a tangent line, is also used to define differentiation. The derivative of f at x is given by this function. So the derivative of f of x is equal to the limit as h approaches 0 of this function, f of x plus h minus f of x over h. Okay? So I'm going to give you some time to write that down and then we'll talk. Before we get into this, guys, what does this mean? If I tell you f of 2, what does that mean? Plug in 2 for x. Correct, right? So that means literally x is x, plug in x. So if I said f of happy face, you would plug in happy face for x. Agreed? So whatever's here, that literally just means plug it in for every x in your function. Is everybody understanding that? Fantastic. Okay, so here we go. It says the limit as h approaches 0 of f of x plus h minus f of x over h. So just by looking at this, do y'all see an issue? H is 0, so I can't plug in because why? Can't have a 0 in the denominator. So do you realize that there is going to be some manipulation going on here, right? Okay, so let's see how this works. Okay, so here we go. We have an example. F of x equals x squared. F of x equals x squared. Okay, so I showed you, you already know the shortcut. So technically you already know the answer. What's my answer? What's the derivative? 2x. Everybody agree with that? Okay, so we already know the answer. That's why I told you the shortcut, so you know if you're doing this right. Okay, so we already know our answer in the end should be 2x. Okay, so I'm going to use that instead though. So what does this mean? So just like what I told you, whatever's here goes in for x. Agreed? Whatever's here goes in for, well, this technically just means the original, right? Because f of x is x squared. Okay? So what is this going to look like? So this is going to look like this. The limit as h approaches 0 of x plus h squared minus x squared over h. Does everybody see what I did? Okay? So the first part says plug in x plus h for your x. So my x was squared. So that's why I have x plus h squared. Right? Minus f of x, minus the original. Minus x squared over h. You with me? Okay, so now guys, obviously, is there still a problem? H is still in the bottom, so I can't, so obviously again, let's try to simplify. Okay, let's try and simplify. Is there anything I can simplify? Well, what is this doing? It's being squared, so let's square it. Okay, so x plus h squared. Okay, let's do some side work. X plus h times x plus h is what? X squared plus xh plus xh plus h squared. Does everybody agree that this is just going to be x squared plus 2xh plus h squared? Right? Does everybody understand what we did there? Right? So here's what I have. I have the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. You with me? You with me? Can I simplify a little bit more? You notice something? The x squareds are going to go away because it's x squared minus x squared, so that goes away. So technically I'm left with 2xh plus h squared over h. Again, there's still an issue, right? There's still an issue. But do you notice something on the top? They both have a what? So then what if I factored out an h? I would be left with 2x plus h over h. Why does that help? Now they'll cancel. So literally I'm left with this. The limit as h approaches 0 of 2x plus h. Now can I plug in h being 0? And if I do, what am I left with? 2x. It's algebra. So if this is the first way you would have learned how to do it. You would have known nothing else. I said this is how you find a derivative, everybody. That's it. Okay? And then later on I would have showed you the shortcut and you'd be like, why didn't you show me that in the first place? So it doesn't matter. Either way, you're going to complain about it. Okay? So, notice what we did. What did we do? You plug in your x plus h. You expand, you simplify, do whatever you have to do, depending on your function, right? If it was squared, you square it. If it's cubed, you're going to cube it, and so on and so forth. And then basically you're simplifying. Kind of my goal, you notice my goal is basically I need to get rid of that h on the bottom somehow because it can't be there, right? And when I do, whatever is left is my derivative. Yes, sir. Why what? Because this is the first way. This is how this is what a derivative actually is. This is what a derivative. The shortcut is, hey, look, shortcuts were obviously. Here's the deal. Okay, when do you find a shortcut? After you've been there. You see what I'm saying? So like the first way you find, that's just the way it is, right? If you're going somewhere, that's just the way it is. It's not until after you've gotten to the final destination that you realize, oh, there was a shortcut. And it's the same thing here. Okay, so after people or whoever mathematicians took derivatives like this forever, they realized, hey, wait a minute, there's a shortcut. You see what I'm saying? Exactly. The reason I teach you this, because if it was just, hey, find the derivative, shortcut all day, right? But exactly what Vanessa said, on the test, they'll tell you, use the definition of a derivative. So you have to know this process, okay? The reason I'm telling you now, the reason I didn't do it in the beginning is because most of the test is find the derivative, use it somehow, right? Okay? But there are a few questions where it's like, use this process. So you have to know it. See what I'm saying? Okay? And it could be one of those process questions, you know, those famous questions that's like, well, here's what little Timmy did. Where did he make his mistake? You know what I'm saying? And then you have to understand where he made his mistake. We okay? Let's try again. Wait a minute. All right. Next example. Next example. So I want us to use the same method on this time x cubed. So what's my answer going to be? So I already know my answer is 3x squared. And isn't this what y'all like? Y'all like to know the answer at in the beginning? That way you know if you did it right. Okay. So, spoiler alert, right? Here we go. Ready? What is it going to look like? So limit as h approaches 0 of what? X plus h cubed minus x cubed over h. Is everybody good with that? We good? Questions? Okay, so now this one's weird because I actually have to cube it this time, right? I actually have to cube it this time. Now, no need in throwing away stuff that we already know. Okay, so how do you cube something? Multiply 3 times. Well, I've already done it twice in the problem before, right? So then I just have to do it one more time. What did we get as, what was x squared? Agreed? So that times one more time of x plus h, okay? Don't throw away stuff that you know, all right? Because you're gonna have to do this all the time, I promise. Does everybody understand where I got this from, right? This was x squared, and then all I'm doing is one more time as x cubed. We good with that? Can you do it? What do I get? X cubed plus 2x squared h plus, all I'm doing is everything first times the x. Xh squared, or h squared x, it doesn't matter. Plus, say that again, x squared h plus plus h cubed. Can I simplify this? Okay, so now be very careful here. Be very careful, because remember, you can only combine like terms. And what does it mean for terms to be alike? Same exponents, same variables. Okay, so x cubed, is there anything like it? No, so obviously that's going to drop down. Okay, 2x squared h, is there anything like that? Yes. Does everybody see my other x squared h? So if I have 2 and then here's another one, so technically I have 3x squared h. Xh squared, is there anything like it? Yes, I have a 2xh squared, so that means I have 3xh squared, and then of course my h cubed. You with me? So then here's what I have. I have the limit as h approaches 0 of x cubed minus 3x squared h plus 3xh squared plus h cubed minus x cubed, all of that over h. Sorry, should be plus, right? Sorry. You with me? Okay, what do you notice? The x cubed is going to cancel out, and the problem is, yes, I still have an h on the bottom. So let's see if I can do, instead of just simplifying and writing it, do y'all notice what I'm going to do to the top? They all have a what? An h. So I take out an h. If I take out an h from everything that's left, what am I left with? And then all that's still over h. But then you notice what? The h's cancel out. So in the end, I'm left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. Now, here's the thing. I can plug in h now, right? But what's going to happen to this? It'll zero out, and this. So essentially, I'm just left with what? Which what we already knew was the answer. Does everybody see how this is going to work? Okay? It's just algebra heavy. You got to be very careful with yourself because it's obviously easy to lose yourself in the algebra, okay? But here's the thing. Now I know what x plus h cubed is, so keep it in your pocket. You know what I'm saying? Why do this again? We've already done it. So we already know what x plus h squared is. We already know what x plus h cubed is. Yes? This one? Okay, so I had to do this x plus h 3 times, right? But in the problem before, I did it twice already. So that was my answer. So if this is twice, and then this was one more time. So technically, this was the x plus h times the x plus h. You know what I'm saying? So that's because that's what I had. If you didn't recognize that, then this is what you would have to done anyway. You would have done the first two, got an answer, and then multiplied it one more time. A cubed? No. But here's the thing. This is always true. It's not just that we did it the problem previous. Anytime, any question asks me for x plus h squared, that's my simplified version. That's why I'm saying keep it in your pocket. You know what I'm saying? Because like later on, what if there's a 3 up front? So then all I know is, oh, I know the answer is going to be this, but then I'm just going to have to multiply everything by 3. You see what I'm saying? Okay? So it's not necessarily that we just used it in the previous problem. It's that that's what it's always going to be. So kind of just keep it handy. Okay? I mean, if you don't keep it handy, fine, then do the algebra. Okay? Like, okay, what if in my next problem, or in any problem, what if it was x plus h to the 4th power? So I could do this one more time. Or couldn't I just do this one twice? Right? See how that works, guys? You see how that works? I'm not saying you have to memorize all of them, but if you have a couple, you can use them however you please. We okay? Does everybody see what we're doing? Essentially, what's the main goal of all this? Yes, but like as far as the algebra, get rid of that h on the bottom. That's technically the only problem, right? Because that is my problem. The problem is I can never, because with limits, as we learned with limits, what you always kind of want to do is plug in, right? Because that's the best thing to do, is plug in. But in this case, bless you, you can't do it. You can't plug in because of that h in the denominator, or that 0 in the denominator. So the goal is to try and get rid of that. Any questions? Okay. Let's pick it up a little bit. Okay? It's actually not that difficult. It's the same thing over and over. So it won't be. So that's a good question. She's like, what if the h to 0 is like a 2 or 3? It can't. This is the rule. Okay? That's the rule for definition of a derivative. When you're doing 2 or 3, now you're finding it at a different point. Okay? So this is the rule. Anytime they say use the definition of a derivative, it's always going to be this. Okay? All right, so here we go. F of x is x squared plus 2x. So let's get my answer. What's my answer? Agreed? All right. Let's do the fun stuff. So this is going to be the limit as h approaches 0 of what? So x plus h squared plus 2x plus h. So because I have 2 x's here, remember this x plus h has to go everywhere. Does everybody get that? So this is my x squared plus 2x. You with me? Right? And then it's going to be minus my original. Don't forget, now because there's more than one thing, I am going to have to add parentheses. Now why do you think I'm going to have to add parentheses? That negative, that minus sign is going to have to be distributed. Okay, so anytime it's more than one term, always put a parentheses because that minus sign is going to have to go to both. You with me? Okay, so here I have to square, but we have it in our pocket. What is it? Is everybody good with that? Right? And then on this, and then here, what am I doing? Just distributing. So that's going to be a what? Plus 2x plus 2h. Right? And then here, again, it's just distributing. So I'll be left with a what? Minus x squared minus 2x. All of that over h. You with me? Okay, notice anything? The x squared gets canceled. And the 2x gets canceled. I have a minus 2x and a plus 2x. So, notice everything that I'm left with. It all has a what? So then what can I do? If I take out an h, what am I left with? 2x plus h plus 2. All of that over h. What do you notice? So then I'm left with the limit as h approaches 0 of 2x plus h plus 2. However, if I plug in 0 for my h, what am I left with? It's like magic, man. We good? Algebra, right? I told you in the first week of calculus, the hardest part of this class is the algebra. Okay? Once you know the calculus concepts, it's good to go. Any questions so far? Are we good? All right. I want everyone, choose one. I don't care which one. Choose it and do it. Challenge yourself, okay? Challenge yourself. I'm going to give you a couple minutes to work on it. I'll walk around, make sure you're doing the right thing, and then we'll move on. So it's going to be 4x plus 1, correct? Right? That's your final answer? So when I do it over here, it's going to be the limit as h approaches 0 of 2x plus h squared plus x plus h minus 1 minus 2x squared plus x minus 1. Now notice I put it in parentheses, and it's all over h. Y'all with me? Okay. Now, my guess is you messed up here probably. What do you do first? You have to do the exponent first. Why? PEMDAS. So do not distribute that 2 until after you've squared. Was that your problem? No? You're good with that? All right, so then, first of all, I know x plus h squared. All right, so I'm going to kind of lengthen this out even though I don't have to. So that 2 I haven't touched. But I know this is going to be x squared plus 2xh plus h squared, right? When I distribute, it'll be 2x squared plus 4xh plus 2h squared. Drop this down, plus x plus h minus 1 minus 2x squared minus x plus 1 over h. Right? Notice that my 2x squared is going to cancel. I have an x that's going to cancel. And I have a 1 that's going to cancel. So everything left has a what in it? An h. When I take out that h, what's left? 4x plus 2h plus 1. Remember, if you factor out an h, there has to be something there to hold its place, right? So then I'm left with the limit as h approaches 0 of 4x plus 2h plus 1. When I plug in 0 there, it's going to 0 out, so I'm left with 4x plus 1. We good? Any questions? Yes. This one? Remember, because my rule says the limit as h approaches 0 of f of x plus h minus f of x. So this is the minus the original part. The minus f of x. You see what I'm saying? Right? You got it? Any others? The 1, because my original had a minus 1. You still have to put it. So this is so when you're plugging in f of x plus h, yes, x plus h goes in for every x, but you can't ignore the rest of the equation. So you still have, if you have a minus, even though this doesn't have an x, it's still part of the equation. Does that make sense? What was your question? Mm-hmm. So you're saying you replace this with a... No, because then you're essentially ignoring it. Because this is always going to be there. The minus is always going to be there. You see what I'm saying? So then you're totally ignoring the minus 1 that was with the original equation. Does that make sense? Any questions, people? So now notice. So far they've been relatively easy, right? So my hope is that you have the question, yes, sir, but what about the hard stuff, like the quotient rule, or chain rule and stuff like that. Do those still work? The answer is yes, of course. This works on all of them. Okay? This works on all of them. So let's look. Oh, let's do something else first. What about finding the derivative at a certain point? Okay, what about finding the derivative at a certain point? So before with the shortcuts, all we did was what? If I told you find the slope of the tangent line at x equals 2, you just plug it in, right? So this is the same thing, but now we're doing it using the definition of a derivative. So basically it's this. It's f of a, so f of whatever point they give you, is the limit as x approaches a. So Alex, here's your question. This can now be anything. This can now be the point that you want, right? Of f of x minus f of a over x minus a. Okay? So here's my formula. It's the derivative at a certain point. The derivative at any point is the limit as x approaches that point of f of x minus f of a over x minus a. Okay? This is exactly like this. Isn't it? Isn't this exactly like this? So why does that make sense that it would be? What does this represent? Slope. What does the derivative represent? Slope of a tangent line. It's literally the same thing. Okay? The only difference is, what's the only difference between this and this? So that's the difference. This is slope of a line. This is slope of a tangent line on any curve. The difference is, because it's the derivative I'm looking at, that's why I'm taking the limit. You see the difference? Okay? So, fantastic connection. That's what I need you to understand. I need you to understand that stuff. Okay? Basically, all I'm doing is finding slope here. That's it. Just finding slope. Okay? So, let's try it. Find the derivative of the function at this given point. So here's my function. F of x equals x squared plus 4, where a is equal to 1. So let me write my rule here. Okay, so here's my rule. It's the limit of as x approaches a of f of x minus f of a over x minus a. Okay, what does f of a mean, by the way? You plug in a into the function. So can I do that real quick? Yeah. So what is f of a? So basically f of 1 is equal to 5. Does everybody understand how I got that? Right? Just plug in 1. 1 squared is 1 plus 4 is 5. We're good? Okay? So then here's what I have. I have the limit as x approaches 1 of f of x, which is x squared plus 4, minus f of a, which is 5, over x minus 1. You with me? No, this is just x minus a. Did everybody see what I did? All I did was plug in my a everywhere I needed an a and all that good stuff. Can I simplify this? So first of all, can I plug this in? No, because if x is 1, what's the problem? It's a 0 in the denominator. You see the issue here? That's why that happens, okay? So, can I simplify this? Let's try. What would I get? Still can't plug in, right? Still can't plug in. Notice something on the top? Good. I can factor the top. X squared minus 1 is technically my x squared 0b, and my c is negative 1. You see what I'm talking about? So can I factor, are there factors of negative 1 that add up to 0? What? So you're telling me that the top is really x plus 1 x minus 1. Agreed? Why does that help? Because now I have an x minus 1 that goes away, therefore there is no more issue. So I have the limit as x approaches 1 of what? X plus 1, which of course now is equal to 2. So the slope at this point of a is equal to 2. So do you see how the similarities between this one and the regular one? My goal was basically trying to get rid of that, right? Because I couldn't plug in at that point. You good? Yes, ma'am. Mm-hmm. This one? Uh-huh. Because, okay, the rule says f of x, which means your original equation. That's why it's x squared plus 4. Minus f of a. That is what we did over here. We plugged in our a was 1. So f of a is 5. Right? So that's why it's x plus 4 minus 5. And then on the bottom, it just says x minus a. Not f of a, your original a. Does that make sense? We good? All right. What time do we get out of here? Okay. Let's try another one. Actually, you try this one. All right. So my rule, just so we have it. Okay. So my rule is the limit as x approaches a of f of x minus f of a over x minus a. What do I need first? F of a. In this case, f of 2. What is f of 2? You should have gotten 12. Right? So then what I have is the limit as x approaches 2 of f of x, which is 2x squared plus 4, minus 12 over x minus 2. At this point, I can't plug in, right? So then, can I simplify the top? 2x squared minus 8 over x minus 2. Can I simplify the top even more? I can factor out a 2. If I take out a 2, I'm left with over x minus 2. Still can't plug in, right? But again, I can factor the x squared minus 4. So do you guys see that these are your special factors, right? So what factors of negative 4 that'll add to 0? So basically I'm left with the limit as x approaches 2 of my 2 that's out there, of x plus 2, x minus 2, all that over x minus 2, and then what do you notice? Those leave. So basically I'm left with the limit as x approaches 2 of x plus 2. And then you can plug in now. 2 plus 2 is, times 2 is 8. Because we write them all the time. We good? Any questions? So what's the difference between this formula and the first formula I gave you? For this one, you have a point. It's at a specific point. Do not get confused with that, all right? So this is for at a specific point. The other one's just in general. Any questions? All right. Exactly. So exactly what you said. You see what you said? She said, couldn't I just do the other one and just plug in a specific point? And the answer is yes. I think this one's a little easier than doing the longer version, right? Okay. All right. So now let's talk about the hard stuff. Okay? Let's talk about the hard stuff. So what about the harder problems, like the quotient, the product, the chain? Okay? Do those still work? And the answer, of course, is absolutely. So, here's my suggestion. Our rule, this is just in general. So notice I don't have a specific point, right? So then what's my formula? Okay? So, here's my suggestion. You guys notice that this is already a quotient, right? And then this is already a quotient. So I'm going to have a quotient on top of another quotient, which can look crazy, can get crazy, correct? Do y'all realize that this, couldn't I just write this as 1 over h times f of x, x plus h minus f of x. Isn't that the same thing? Right? Instead of dividing by h, I can just multiply by a fraction of 1h. Does that make sense? You guys agree with that? Okay, so they're literally the same thing. So then what I'm going to do is this. I'm going to take the limit as h approaches 0 of 1 over h. Now, do what we do. Plug in my x plus h. Be very careful here. Ready? Plug in my x plus h. X plus h over x plus h plus 1 minus x over x plus 1. Does everybody understand what we just did? We good? Yes, no, maybe so? We good? Okay. Okay, guys. So now, here's the issue. I still can't plug in, right? Because if I plug in a 0 here, it's undefined, blah, blah, blah. I still can't do that. Okay? So again, I am going to eventually have to try and get rid of this h somehow. Okay? In the inside, I have, break it down into the easiest possible thinking. I have two fractions, and they're subtracting. What's the issue? They have to have common denominators. Do they have common denominators? No. And do not say, oh, look, that one's just missing a plus h. I can just add a plus h. You can't do that. How do you get common denominators when you multiply a fraction, right? So, like, think about it this way. If you were doing 1/2 minus 2/3, how do you get them to become common denominators? You multiply them by each other. So this one becomes, you multiply this one by 3 to get the 6. You multiply this one by 2 to get the 6, right? Same concept, people. Okay, same exact concept. I am going to multiply this one by what? X plus 1. And I'm going to multiply this one by x plus h plus 1. But remember, whatever I do on the bottom, I have to do to the top. Is everybody with me on that? Okay, so let's pay attention very, very carefully here. On the top, so x plus h times x plus 1. Right? What is that going to give me? X squared plus xh plus h. Wouldn't it be another xh? Right? Because it was, okay, so it's x times x squared, x times h, which is xh. Now, oh, plus x plus h, my bad. You with me? Minus, on the bottom, x squared plus xh plus x. So you realize that these are subtracting, right? And it's all over the common denominator of what? I'm going to leave that for now, just for a second. Just for a second. Or should I distribute? Should I? We'll see. We'll see. I might have to. So do you see what I'm thinking, right? Because right now, let me just leave it. Maybe something will cancel, like on the other stuff. Or I might have to actually multiply it. But who knows? We'll figure it out. So you see what's going to happen on the back? What? So can I do that now? Are y'all okay if I do that now? So if I do that now, this becomes minus, this becomes minus. Agreed? Okay, now simplify. I still have my 1 over h on the outside. The x squareds cancel. The xh cancels. The x cancels. So I'm just left with what? H on the top, x plus 1, or x plus h plus 1 times x plus 1 on the bottom. You notice something. These are already canceled. Right? Because 1 on top, 1 on bottom. By rule, if you're multiplying fractions, they will cancel. So what's left, people? 1 over x plus h plus 1, x plus 1. Okay? If I plug in h, what's going to, bless you. If I plug in h, what's going to happen? That goes away. So what am I left with? Which is technically so by magic it still works. This rule still works, okay? There's just, again, just some manipulation, but again, it's all algebra. It's algebra. How good is your algebra? Any questions on this one? So, what's my kind of my advice when you're dealing with rationals? Don't think of it as all over h, think of it as what? 1h, 1 over h times all that, okay? It's just much easier. Much easier. Okay? All right, last one of the day. Your favorite? Radicals. Radicals. What do we got, like 10 minutes? More than enough. Can we do the shortcut first just to make sure we're getting the right answer? All right, let's do that. How would I do this? First of all, what would I do with this? Right? And then when I took the derivative, what rule would it be actually? Chain rule. Why is it the chain? There's two functions, one's inside the other, correct? So then what would it be? So 1/2 come out of the front. 5x minus 8 negative 1/2 times just 5. Good. So then if I simplified this, does everybody realize that it's going to be 5 over 2, and then I bring this to the bottom, correct? Square root of 5x minus 8. You understand that? What I'm doing? Or what I did? Right? Because this becomes 5/2, so it's already a fraction, 5/2. And then since that's negative, I want it to the bottom, and I switch it back to a radical. All in one motion. You good with that? Okay, so that's my answer. I know my answer. Now let's do the fun way. Okay? So, for my fun way, it's a limit as h approaches 0 of what? And I'm not going to switch this. I am not going to switch this to an exponent. I'm going to leave it as a radical. So what would it look like? You with me? Minus all that over h. Simplify that. Simplify that at least a little bit. This would be the limit as h approaches 0 of the square root of 5x plus 5h minus 8 minus the square root of 5x minus 8 over h. Now let's see how good your memory is. I have a radical that has a rational. I have a radical. All right. Do you guys remember how to deal with radicals and rational functions? After you're done crying, what do? Why? By what though? The complex conjugate. You remember that? You're going to multiply this by basically itself, except one big major issue. So, this is going to be... Yeah? All right. Now, everybody have their seatbelt on? Okay. Well, pretend we're on a school bus then. That's my point. That's my point. My point. Every time I get on the bus and I I was like, okay, everybody buckle up, and I put mine on. And they're like, what? All right, okay. When you're dealing with the complex conjugate, okay, you're technically foiling, but there was a trick. What's the trick? The middle goes away. So you really don't have to, because one's plus, one's minus. Imagine if it was like x plus 2 times x minus 2, right? Technically, the 2x and the minus 2x in the middle will go away, right? Guys, the same concept here. So don't freak out, because I'm only going to do two multiplications, the front two and the back two. But this only works when they're complex conjugates. Okay? So guys, what happens when I multiply a radical times itself? You're squaring it, so the radical goes away. So basically, do you see that I'm going to be left with 5x plus 5h minus 8, right? And then it's the same thing with the back. The radical will go away, but it's minus, so be very careful. 5x minus 8 over, and then on the bottom, I'm going to keep that for 1 second. Okay, so don't freak out. Tuck and roll. Okay? So, see what's going to happen, guys? In the back? What's going to happen? This is going to become minus. This is going to become plus. And then what do you notice? 5x's cancel. The 8's cancel. So, what am I left with? 5h over all that stuff. Very good. So she said, oh, the h's will cancel out too. Agreed? So look, here's what I have. I have the limit as h approaches 0 of 5 over square root of 5x plus 5h plus minus 8 minus 8 plus the square root of 5x minus 8. Can I plug in my h now? Yeah, technically, because the only thing that's going to zero out is that. And so do you see something? You're left with 5x, radical of 5x minus 8, plus the radical of 5x minus 8. Isn't that 2 radicals of 5x minus 8? So, if I plug in 0, this goes away. So then I'm just left with 5x minus the radical square root of 5x minus 8 plus another radical or square root of 5x minus 8, which, and since they're the same thing, I can combine like terms into 2 square root of 5x minus 8. Okay? So, algebra, algebra, algebra. Get used to it.